All right, guys, today we're starting with the identity and equality properties. Identity and equality properties. All right, so there are several of them we're going to look at today. Some of them are very basic and straightforward. I hope you get them down quickly, and I'll give some examples for each one. But then the last four basically are the ones that are a little bit newer, okay? So we're going to talk about those a little bit more. Okay, so if you're on page 37, what's the first yellow box titled? The first property?
Additive.
Additive what? Identity. Additive identity. All right, and if you're looking at that, it says for any number, what is it trying to tell me with the additive identity? What's the additive identity property? Again, we talked about this not too long ago. Jack?
Any number a plus 0 equals 0 plus a equals a.
Yeah, and I want you to write this down. Any number plus 0 is going to equal that number, okay? And what numbers are we talking about? It gave you a description at the very beginning of the definition. It says for any number. Does that include a fraction? Decimal? Positive? Negative? Any number a plus 0 equals a. Okay, that's it. That's the additive identity. Give me a number, Lucy. 3 plus 0 equals 3. So anything added with 0 gives me that same thing. I hope you remember that. That's one of the review ones. Second property, if you turn the page to 38, I believe. 38. Next one. Multiplicative identity. We're going to show you how we actually use them toward the end, but we're just kind of going through these properties fairly quickly. What's the multiplicative identity for any number? Nate.
A times 1 equals 1 times a equals a.
A times 1 basically equals A. Any number times 1 is the same number. Give me a negative number, Harrison. Negative 4. What's negative 4 times 1? Negative 4. All right, on both of these guys, did A ever change? Did A ever change? No. So it kept its identity. That's how we keep that identity. But guys, you don't always see it in this way. You don't always see it as just 0. You might see it as A plus 0 over 5. Uh-oh. What's 0 over 5? It's also 0. You might see this as 2 over 2. What's a number times 2 over 2? The same number. Okay? So you can see in different ways. We will as the year goes on. All right, third property. The multiplicative property of 0. Multiplicative property of 0. So 0 has its own special multiplicative property. Lily, Mooney, what is the multiplicative property of 0?
Any number times 0 is 0.
Whoa. Any number, we're just going to call it A, times 0 equals 0. Okay? So, Lily Guerrero, give me a fraction. 1/2. What's 1/2 times 0? 0. Okay? Positive, negative, decimal fraction, doesn't matter. That's always going to be true. This one's one of my favorite properties, especially like 3/4 of the year in. We're going to look at the 0 factor theorem. Okay? 0. I get that word. What's factor mean? Part of a multiplication problem. Theorem. Okay. It's saying this. Whenever you get a product of 0, one of the numbers being multiplied had to be So listen to me. Look at the board, watch where I'm pointing, and watch and listen to my words. If your product is 0, so you have a product to multiplication problem, and it's 0, one or both of these numbers had to be 0. Isn't that true? Okay? So if you don't know what the factors are, you know at least that one of them had to be 0 if your product was 0. We'll definitely review that later. Okay. Uh-oh. The next one? Matt, what's the next one? It's a tough word. Good, multiplicative inverse property. I'll put here multiplicative inverse. Okay. I'll give you, or actually, can someone kind of read me that definition? It's long, it could be complicated, but do your best to read it. The first part you would read, for every non-zero number, A over B. Okay, you can say A over B. All right, Claire, read that.
For any non-zero number, A over B, where A
And B.
and B does not equal 0, there is exactly one number, A over B.
Oh, sorry, there's exactly one number.
Oh, sorry, B over A.
Such that
A over B times B over A.
Yeah, that's a tough one, isn't it? It's even tough to read. Like, even I'm looking at it and saying, okay, I better say it right. For every non-zero number, A over B. So can A and B be 0 according to this definition? No, it has to be any non-zero number. There's exactly one value, B over A, where if you multiply A over B times B over A, you're going to get 1. Okay, let's use an example here before I write that down. Actually, let me give you the formal way, and then we'll get the example. So A over B times B over A should give me what? 1. How do you know that without knowing the numbers? I mean, how do you, like, really? Are you sure that's going to be B over, or 1? Nate?
Well, plus your reciprocal is the reciprocal times the regular number is 1.
That sounds good. So give me a number. Abby, can you give me a fraction? Not too hard.
1/2.
1/2. Our favorite fraction, right? 1/2. Okay, let's call A 1 and B 2. All right? So what's the B over A over here? Anybody? Yes, ma'am? 2 over 1. And what do these two fractions multiply to get me? 1. Or 2 over 2, right? Which is a big fat 1. Okay, listen to me carefully, guys. 1/2 and 2 over 1 are reciprocals. Do you guys remember reciprocals? Okay, look in your book here, 38. Look at example 1. Someone read me those instructions. Jackson, example 1, read the instructions.
Name the multiplicative inverse of each number variable.
And then keep going.
Assume that no variable equals 0.
Jackson's okay. He sounds different. Okay. Assume that no fraction or number equals 0. So it's just saying get the multiplicative inverse. Okay, you know what you can substitute multiplicative inverse with? What word you can substitute that phrase with? Reciprocal. Reciprocal. And I'm going to make sure I spell this correctly. We're talking about reciprocals. Reciprocals. Okay? Do you guys remember that word a little bit? Ready? You guys remember it? Okay, don't look at your books. You can write these in your notes. These next prompts I'll give you, but don't write them in your notes just yet. Or, sorry, excuse me. Don't look at the book, but you can write things down in your notebook. All right. So example 1 we're looking at right here, and we're going to do 3 of them. What is the multiplicative inverse of the number 5? What's the multiplicative inverse of 5? Matt? 1/5 is the answer. 1/5. How do I know it's the multiplicative inverse? Because 1/5 times 5 is going to get me what? 1. Okay? So 5 has a unique number. The reciprocal, which is this. When they are multiplied, what am I going to always get? I have to get 1, ultimately 1. All right, let's do B. B is, x. What's the multiplicative inverse of x, Carrick?
1 over x.
1 over x. That is done. Because what do I know about these two? Tell me a little fact here. I'm trying to pull back from what I'm telling you. Jack, what do I know about these two?
If the x was like 2, then it would be 1 over 2, which 1 over 2 and 2 are the same thing.
Close. 1 over 2 and 2 are reciprocals because when they are together they equal. Do you see what I'm trying to say? I don't know what these numbers are, but I know if these two values were multiplied together, what would I get? 1. So they're reciprocals on one another. All right, and last one, 2/3 for this example. 2/3. What's the multiplicative inverse of 2/3? Harrison?
3 over 2.
3 over 2. That's the answer. That's it. Can everyone find the multiplicative inverse of a number? You guys good on that? Because your first few problems are going to say, find the multiplicative inverse of these numbers. That's all you have to do. Find the reciprocal of those numbers.
Doesn't that equal 1?
So, if I multiply them together, yes, that would equal 1. But all I'm saying is, what is the reciprocal of this number? It's this. They just want to know what's that other number. All right, any questions on that so far? Have we dealt with most of the stuff before, though? Let's get to the new stuff. Done, done, done. Okay, thank you. Thank you for the sound effect. We will edit that out later. Okay, page 39. Oh, we didn't talk about this in our class. The other class brought it up. I need somebody who's quick. You're not going to run anywhere. I just need somebody who's quick. I see that hand, Matt. Matt, I saw him actually during break. Harrison was running for the touchdown, and Matt was coming closer. I was like, okay, I think he's going to, oh my goodness. Matt tagged him right at the 2-yard line, 1-yard line, goal line. Matt, you're pretty quick. Okay, now Matt, what I want him to do is simply do what he would normally do in this situation. Ready, Matt? Ready? Okay, what did Matt do? Now, I wasn't aiming for your face or to hurt you, but what did Matt do?
Caught it.
He at least attempted to catch it. Why? Because he thought about it. He was like, Mr. A just threw a marker. Must get hands up. Catch. Can you throw it back to me? Oh. Swivl. We're gonna record this. We're gonna win this case. Mr. A versus Matt in the court of law. All right, guys, don't worry. I'm okay. All right, listen up. Matt did what when I threw that pen? He didn't think about it. He reacted. Have you heard of reaction time? Okay. What caused him to react that way, to put his hands up? Reflexes, right? Reflexes. You know how your doctor tests your kneecap? If he hits it, he hopes that you're going to respond to it. Sometimes quickly, sometimes not, depending on your reflexes. But this is what we're testing out, reflexes. If I threw this at you and it's coming toward your face, at least some of you are going to do this. Some of you are going to do this. And some of you are going to do this. And you're going to, depending on your reflexes, but there are things you do automatically, okay? Let's look at the first property, reflexive. This is a cool property. Reflexive property. I'll just call it reflexive. Ready? Steep. So pay attention. A equals A. Nice. For any number A equals itself. We got it on camera. Will it be edited? probably. I hope it doesn't get me cringing in pain.
You want
That'll get
a
so
reason to
confused.
get me watching.
Yeah.
Yeah.
All right, hold on. The reason is math. But anyway, guys, none of us really had to think too hard about that. Wait, yeah, a number equals itself. So give me a number. Yes?
8.
Doesn't 8 equal 8?
Yeah.
Automatically, okay? That's a reflexive property. It says, boom, a number equals itself, which seems pretty basic, but there is a use for it, and we'll get to that as we go through this book. All right, the next one, symmetric. That was easy, I hope. Symmetric. What's symmetry? Yeah, what is that, though? Symmetric property.
For any number A and B, if A is equal to B, then B is equal to A.
All right, that's all it is. By the way, reflexive property, I should actually put this, reflexive property of equality. These properties that we're talking from here on out are all with equality. So what does equality refer to? An equal sign. These properties have to be shown with equal signs in the problems themselves. The other ones did not. All right, reflexive property of equality, a number equals itself. Very straightforward. Here's the next one. Symmetric property, A plus B equals, ready for it? B plus, oh, I wasn't ready for it. B plus A. Oh, that's deep. Now, it has to be shown this way. This kind of looks like commutative property, but it's actually the symmetric property. Give me two numbers. Not too hard, please. Harrison?
9 and 4.
9 and 4. Okay. What's 9 plus 4?
13.
Okay. 9 plus 4. Make sure I write these before I forget. Is equal to 4 plus 9. Same problem. Same problem. You could say 9 times 4 is equal to 4 times 9. Right? It's a symmetric property here. Okay. Transitive property. This is where these next two get a little bit tricky if we're not too careful. So, transitive property. Transitive property of equality. So again, I'll put these quotations for of equality. Transitive property. This one's a little bit more of thinking when you have to deal with this property here. Can someone read for me that box, Nate?
For any numbers A, B, and C, if A equals B and B equals C, then A equals C.
Oh my, what? Okay, let's write that down. If A equals B and, is it A equals C or B equals C? B equals C. I want to make sure I write it the way they do. So if A equals B and B equals C, then A equals C. Okay, so write that down. We'll actually get some numbers going here. Okay, Karen? It's a motorcycle. Okay, give me some numbers here, but they have to fit this properly. And I'll help you if you're struggling with it. Lily, Mooney. So give me a number for A, just any number.
7.
Okay, A is 7. Now B, give me any sum that equals 7. Any sum that equals 7.
Wait,
Any sum. Pick any numbers that can add up to be 7. 2 numbers is good. Okay, 4 plus 3. All right, how many of you agree with this statement? Okay, so far so good. Okay, and then let's get B. It's still 4 plus 3. And that equals, ready for it? 14 over 2. Is that true? Okay, so far so good. Okay, if this is true and that is true, give me another statement of equality with these two in mind. Maggie. What? You serious about that? I know that 7 equals 4 plus 3, and I know 4 plus 3 equals 14 over 2, but really? Okay, I gave you these two statements. From those two statements, you can come up with this right here, right? And is this true, by the way? Yes, because if this is true and that is true, this must be true. Have you guys ever heard of if-then statements? They're conditional statements. If it rains today, I will not have practice after school. It rained today. What happens, therefore? We don't have practice today. Do you see what I'm saying? That's a conditional statement. And in this case, it fulfilled with the weather here. Question?
Can I get to the restroom?
No. Last property, and then I'm done with properties. Substitution property. Substitution property. And again, this is of equality. Substitution property of equality. In a few months, probably after Christmas break, we're going to go over substitution. Like it's a formal way of working out problems. Substitution. And we're going to, at first, maybe struggle with it. It'll be like, what are we doing here? But we're using this property and other properties to help us figure it out. So substitution property of equality means this. If A equals B, then A may, and I think they probably wrote it differently, but it's the same thing. A may replace B. I think they may have written then if that. Sorry. If A equals B, then A may replace B, or you could say it the reverse way, B may replace A. You could say it either way. Have we ever used substitution before?
Substitution teachers.
Good. Have we used substitution before?
Yes.
Yes, ma'am? This summer, yes. Some of you this summer. What? Actually, all of us used it this summer. All of you did. I'll get to that after, but what I'm saying is that we used this in math at least last year, and then for every other year you've ever learned math, in kindergarten included. Okay, yes?
So how do we use this summer?
Okay, let me work out the problems, and then I'll give you an example of how everyone did it. But let me show you the mathematical way, and then maybe you guys will be able to say, oh yeah, we
We
have.
get $5 if we didn't do it.
Yes, you can have 500 if you want.
Okay.
Just ask your parents, and if they give it to you, great. Oh, you were asking me.
Yeah.
Okay. You didn't say please, so no. All right, 41, page 41. Let's look at how we apply these. Page 41. Did you guys see numbers 9 through 15? I want you guys to try those out. Match that equation or that expression with the correct property.
9 through what?
9 through 15? Oh. By the way, you don't have to write the whole property out. You can use A, B, C, D, E, F, or G. Each one has one and only one answer. So none of them are going to have the same letter. One for each. Just for a little bit more, Karen. Almost done. Okay, let's see if we can at least start this off. Number 9. Which property is being shown there? Number 9. Raise your hand, sorry. Raise your hand. Number 9. Yes, Lucy, I see that hand.
C.
The multiplicative property of 0, C, should be for number 9. All right, number 10. 1 times 68 equals 68. Claire, did you get number 10? No? Harrison?
B.
B, multiplicative identity property. Any number times 1 is that number. 11. 14 plus 16 equals 14 plus 16. That's deep. Jackson.
F.
Close. Not F. So if you got F on that one, that's okay. What's the other one that may fit it better? Or does fit it better? Carson?
Reflexive?
E, reflexive. Any number equals itself. It's just straight up 14 plus 16 equals 14 plus 16, or whatever the numbers were. They just equal each other. That's reflexive, automatically. That's E for number 11. 12. Oh, my. Oh, my. Uh-oh. Let me actually write that one down, and I'll show you. 9. What is it, 9 minus 7?
Yep.
Times 5?
Is equal to 2 times.
Okay. All right. Order of operations, what would I do here?
9 minus 7.
And what's that?
16.
9 minus 7, 2. And then 5 here, right? So isn't this what they give you? 9 minus 7 equals 2 times 5. All right, something like that. Okay, which property is being used? Lily? What? The substitution, is that letter G? That is correct. Substitution property. Now, let me ask you this. Ready? Have you ever substituted one number for two numbers? Have you ever done this? You had two numbers being added, multiplied, divided, whatever, and you substituted with another number. Have you ever done that in your life? That's substitution. Remember how your teacher, when you were just yay tall, and you were so anxious? Oh, I want to answer. Me. What's 1 plus 1? 2. You know what you did? You took 1 plus 1, and you could have easily said, 1 plus 1 is equal to 1 plus 1. Good job. That's a reflexive property. Is that what you said? 1 plus 1 when you were asked 1 plus 1? I hope not. And if you did, your teacher kindly took you aside, patted you on the head, and said no. What you did was 1 plus 1 equals 2. You substituted the number 2 for 1 plus 1. Do you see what you did? You substituted. Okay. Have you ever done that before? Now the question was, have you done that this summer? Yes. You did it. Anyone watch sports? Anyone play sports? Anyone play games? Video games? Any games? Board games? Did anyone read anything?
Oh, definitely. Yeah.
No way.
Did anyone at all use money in any way? Did anyone receive money, give money, use money? If you were any of those, which some of you are like, nuh-uh, I never did. Okay, you used it. You used substitution. You substituted one thing for another, a substitution. All right, let's go with number 13. 13. Abby, what'd you get for 13? D. Which is the, D is the multiplicative inverse. You have a number times its reciprocal, and that equals 1. Question? Okay. Number 14, Claire. A, additive identity. Additive identity. And number 15, by the way, process of elimination. You've gotten rid of all the letters except for one, so you got to have the last one be F. And that one would be the symmetric property. So 8 plus 1 equals 9. So 9 equals 8 plus 1. That's just reflexive, or symmetric. Sorry, I said reflexive. Symmetric. 8 plus 1 equals 9. Therefore, 9 plus 9 equals 8 plus 1. Wow, that's hard to say. How many of you got all of these the first time?
Nope.
Okay, how many of you struggled in this area right here?
Yep.
At all? Maybe you missed one, two, all of them? Okay, sorry, how many of you got them all right? Oh, okay, some of you did. Okay, good. Sorry, I thought no one got them all right. All right, let's see here. Carson, what's our time?
1 and 3.
Perfect. We're almost done. Last thing, guys, last thing.
Just holding in Eric.
Really?
It's like my time schedule.
Okay. Well, we're going to change that. So kind of like my son Titus. All right, write this problem down. This is number 16, please. Make sure you're not just watching. Careful, guys. Don't throw things around, especially when someone's not paying attention, because the reflexes might not respond. All right. So here you have number 16, and this is what you're going to be able to do. You're going to be able to justify each thing you do using one of those properties that we've learned. Okay, somebody tell me what's my first step to work out this problem. And in this, guys, by the way, in this problem, they gave you each step, but you should be able to come up with that step as well. What's the first thing I do mathematically? Order of operations. Jack.
We multiply, and 14 times 1 and 14 is exactly 0. 1.
All right, so here we go. All right, how many of you understand what I'm doing right here?
Yes.
That you got 14 times 1/14 is 1. Which property was just used there when you simplified this into that? Lily?
The multiplicative inverse.
Multiplicative, and you can abbreviate multiplicative inverse. Okay, multiplicative inverse property. Right? Didn't you do a number times its reciprocal just now? And you got it 1? That's the multiplicative inverse. That tells me, all right, not only did I see what you did, but oh, you used a property. Guys, in every single step on any problem, you are using a property. And we just got to know what it is. All right, next step. Jackson. Yes, 8 times 0. So what's 8 times 0?
0.
Which property was just used now when you did 8 times 0? Multiplicative property of 0. Multiplicative property of 0. You can abbreviate. I'm totally okay with that. Don't give me just symbols, though, because I want you to show me that you understand, and there's no doubt. Multiplicative property of 0. All right, what would you do next? Math in this problem here. 1 plus 0, what does that get you? 1. Which property was just used there? Jack? Additive identity. And I'll put additive ident. Additive identity. Okay, that's it. And then that's it, right? You just simplify it, you're done? No, there's more. Last step?
Oh.
All right, and you get your 12. Which property was used there? Yes, ma'am? Substitute. Multiplicative. That's good. Okay, there you go. Multiplicative identity. There you go. Did you justify all your steps? Like you said, what you did and what property you used. Is that true?
Yes.
You're going to be able to do that on your homework. All right. Oh, okay. Yeah, you get that out. Yes, got that out. Okay, then you just do it. All right, anyway, here's your homework. 23 to 41. 23 to 41.
Odd.
Yes, odds and evens. All right, I'm going to end the